Let's look at how to take the derivative of a quotient. So if your function f of x has a numerator, which I'll call u, and a denominator, which I'll call v, here's its derivative. F prime of x is going to equal u prime v minus uv prime all over v squared. A couple of things you want to notice. First of all, this numerator looks a lot like the product rule. You see a u prime v and a uv prime. The big difference, though, is that in the quotient rule, you're subtracting those two expressions, whereas in the product rule, you're adding them. So, in the quotient rule, the order in which you do these is important. In the product rule, you can switch this with that and still get the right answer. All right, let's see how it plays out in an example. I'll move this up a little bit, maybe pull out a different color. And let's look at this function. F of x equals x to the fifth over the sine of 8x. Let's see if we can write its derivative. So f prime of x will be u prime v minus u v prime all over v squared. And that's all you have to do. Now, what I'd like to do before we finish up here is show you why it works. And we can see why it works by turning our quotient into a product. So I'm going to do that, and I'll do it in a different color. So we have our function f of x. That's u over v. And we can rewrite it as a product, u times v to the negative 1. And what we'll do now is differentiate this as a product and see whether the resulting expression is indeed the quotient rule. So we're going to take the derivative now. Whoops, let me move it back up. Get the pen out. So the derivative of this product is the derivative of the first times the second plus the first times the derivative of the second. And this is a composite function. It has an exponent, but it also has an interior v. So I'm going to have to use the power rule first and then the chain rule. So here it goes to take the derivative of the second. We're going to get negative 1 v to the negative second times v prime. And that's because of the chain rule. That function v right there might have a derivative, so we have to list it off to the right. All right, let's clean this up doing a little algebra now. So I'm going to write this first term as a quotient. So we're going to get u prime over v. And I'm going to write the second term as a quotient. And it will be a subtraction because of that negative 1. And what I'm going to have here is u and v prime all over v squared. Now you might remember from your algebra days that in order to do this subtraction we need common denominators. So we'll multiply this denominator by v and then that numerator by v, and then we'll be able to subtract those fractions. So here goes. We're going to get u prime v minus uv prime all over v squared. And that checks out. That's exactly the quotient rule that we had used a little bit earlier. Now, before I let you go, I want to just give you a little suggestion about how to remember this quotient rule, because this expression is sort of messy. And you can remember it as u prime v minus uv prime all over v squared. But you might also like this way of remembering it. You can think of it this way. If you think of u as your numerator and v as your denominator, then this expression is low d high minus high d low, draw the line, and square below. So low d high minus high d low, draw the line and square below. That's it.